Hi, in this video we're going to practice stoichiometry math problems. I'm going to try to show you all the possible cases of stoichiometry math problems, like if the given quantity is in grams and the unknown quantity is in grams also, or if the given quantity is in moles while the unknown is in grams, if the given quantity is in grams while the unknown is in moles, and finally if the given quantity is in grams while the unknown quantity is in a different unit of mass like kilograms. Welcome to schoolaa, your online school. You may check your understanding by solving the individual questions. And good luck. Let's start with one of the cases of stoichiometry mass problems. Here we have 1.6 grams of methane and we want to calculate the grams of water. So here we start with grams and the amount to be calculated is in grams. Before we do anything, we should balance the chemical reaction. If you don't know how to balance, there will be a useful link in the description. We multiply water by 2, then oxygen by 2, and now the equation is balanced. And as I mentioned in the previous video, that balanced chemical equations in stoichiometry problems, it works like a recipe. It shows the moles proportions between reactants and products, which means that here 1 mole of methane reacts with 2 moles of oxygen to produce 2 moles of water and 1 mole of carbon dioxide. So from the balanced chemical equation, we can have a relation between the moles of the reactants and the moles of the products. So we start with the given quantity, which is 1.6 grams of methane. We convert it to moles of methane, then moles of water, then the quantity that we want, which is grams of water. And I know that now you are asking yourself why we didn't simply convert from grams of methane to grams of water. And this is impossible since we don't have a relation between grams of methane and grams of water. The only relation that we have is between moles of methane and moles of water, and this we can get it from the balanced chemical equation, and it's called the mole ratio. We covered it in the previous video where you put the unit of the given quantity in the denominator and the unit of the required amount in the numerator, which means moles of methane in the denominator and moles of water in the numerator. And the coefficients, we get them from the chemical equation. And now I want you to watch carefully, since this is the procedure that we are going to follow in solving all our stoichiometry problems. We start with the given, which is 1.6 grams of methane, and then we multiply it with a fraction. Since we have grams of methane in the given, we put it in the denominator to be cancelled, and the numerator we put the unit that we want. In this case, we want to convert grams of methane to moles of methane according to the steps we draw above. And usually to convert from grams to moles, we put 1 next to the moles, and we get the molar mass from the periodic table, and we put it next to the grams. So here we look at the molar mass of carbon to the nearest tenth, it is 12, and hydrogen to the nearest tenth, it is 1. So the molar mass of CH4, it's 16 grams per mole. So we put 16 next to the grams. And by the way, I will keep a link in the description to show you how to convert between grams and moles. And in the next step, we convert moles of methane to moles of water by multiplying it with a fraction. Since moles of methane in the numerator, we put it in the denominator, and the unit that we want, which is moles of water, we put it in the numerator. The coefficients, we get them from the reaction. Next to water, we put 2. Next to methane, we put 1. We get these coefficients, as I told you, from the balanced chemical equation. Then we convert moles of water to grams of water by putting moles of water in the denominator and grams of water in the numerator. The conversion between moles and grams, as I told you, we refer to the periodic table. We put 1 next to the moles, and then we find the molar mass of water in the periodic table. The molar mass of oxygen to the nearest tenth is 16. The molar mass of hydrogen to the nearest tenth, it is 1. So the molar mass of H2O, it's going to be 18. And then we write 18 next to the grams. Then we cancel similar units between numerators and denominators to match the final unit with the unit of the answer that we want to calculate, grams of water. Then we multiply all the numerators, we divide them by all the denominators to get the answer, 3.6 grams of water. Another exercise: how many grams of carbon dioxide will be produced when 0.2 moles of carbon monoxide reacts with iron 3 oxide? Here is the given as 0.2 moles of carbon monoxide, and the question is about how many grams of carbon dioxide. Always we start by checking if the chemical equation is balanced or not. To balance this chemical equation, we multiply iron by 2, then carbon dioxide by 3, and carbon monoxide by 3. And now my advice for you when you solve stoichiometry problems is to draw a sketch of the steps that you want to follow while solving. Like here, we start with the given, which is moles of carbon monoxide. We convert it to moles of carbon dioxide by using the balanced chemical equation. Then we convert the moles of carbon dioxide to grams of carbon dioxide by using the periodic table as we mentioned before. We start with the given 0.2 moles of carbon monoxide. We multiply it with a fraction. We put moles of carbon monoxide in the denominator and moles of carbon dioxide in the numerator. We get the coefficients from the balanced chemical equation: 3 next to the carbon dioxide and 3 next to the carbon monoxide. Then we multiply it with another fraction to convert the moles of carbon dioxide into grams of carbon dioxide. You put 1 next to the moles of carbon dioxide, and we get the molar mass of carbon dioxide from the periodic table. As you can see, the molar mass of carbon to the nearest tenth is 12. The molar mass of oxygen to the nearest tenth is 16. So the molar mass of carbon dioxide is going to be 44. So we put 44 next to grams of carbon dioxide. And then we cancel similar units between numerators and denominators. We multiply all numerators together. We divide them by the denominators. And the answer is going to be 8.8 grams of carbon dioxide. Now what if the given quantity is in grams and the amount we want to calculate is in moles? Like in the following examples, how many moles of sulfuric acid will be needed to react with 12 grams of magnesium? First, we check if the chemical equation is balanced or not. It is balanced. Now we write the steps that we are going to follow. We have grams of magnesium. We want to convert it to moles of magnesium. Then we convert it to moles of sulfuric acid. We start with the given 12 grams of magnesium. We multiply it with a fraction. Since here the unit is grams of magnesium, we put grams of magnesium in the denominator, and the unit that we want, moles of magnesium, in the numerator. We put 1 next to the moles and the molar mass next to the grams. We get the molar mass from the periodic table. As you can see, the molar mass of magnesium in the periodic table to the nearest whole number is 24. So we put 24 next to the grams of magnesium, and then we multiply with another fraction. To convert moles of magnesium to moles of sulfuric acid, we put moles of magnesium in the denominator and moles of sulfuric acid in the numerator. We get the coefficients from the chemical reaction, 1 next to magnesium and 1 next to sulfuric acid. We cancel similar units between numerators and denominators, and then we get the answer 0.5 moles of sulfuric acid. And here is our final exercise about stoichiometry mass problems. How many kilograms of potassium chloride will be produced by the decomposition of 100 grams of potassium chlorate? Here, the given amount is in grams, while the amount that you want to calculate is in kilograms. Before we write our steps, we should balance the chemical equation. We multiply oxygen by 3, then potassium chlorate and potassium chloride by 2. The steps are going to be as follows. We start with the given quantity, grams of potassium chlorate. We convert it to moles of potassium chlorate by using the periodic table. Then we convert moles of potassium chlorate to moles of potassium chloride using the mole ratio. Then we convert moles of potassium chloride to grams of potassium chloride by using the periodic table. And then we convert grams of potassium chloride to kilograms of potassium chloride by using the conversion factor between grams and kilograms. So we start with the given 100 grams of potassium chlorate. We multiply it with a fraction. We put grams of potassium chlorate in the denominator and moles of potassium chlorate in the numerator. We put 1 next to the moles, and we get the molar mass from the periodic table. As you can see, the molar mass of potassium to the nearest tenth is 39.1. The molar mass of chlorine to the nearest tenth is 35.5, and the molar mass of oxygen to the nearest tenth is 16. So the molar mass of potassium chlorate is 122.6. So we write 122.6 next to grams of potassium chlorate, and then we multiply with another fraction. We put moles of potassium chlorate in the denominator and moles of potassium chloride in the numerator. We get their coefficients from the balanced chemical reaction. Then we multiply with another fraction where moles of potassium chloride are in the denominator and grams of potassium chloride in the numerator. We put 1 next to moles of potassium chloride, and then we find the molar mass of potassium chloride from the periodic table. The molar mass of potassium to the nearest tenth is 39.1, while the molar mass of chlorine to the nearest tenth is 35.5. So the molar mass of potassium chloride is going to be 74.6. So we write 74.6 next to grams of potassium chloride, and then we multiply with a fraction to convert grams to kilograms, grams in the denominator and kilograms in the numerator, for grams to be cancelled with the grams. And since 1 kilogram is equal to 1000 grams, so we put 1 next to kilograms and 1000 next to grams, and this is, by the way, it's called conversion factor. I will keep a link for you in the description to teach you how to write conversion factors. We cancel similar units. We multiply all numerators together and then we divide by the denominators. The answer is going to be 0.061 kilograms of potassium chloride. To summarize what we have learned in this video on how to solve stoichiometry problems, my advice is always to start by drawing a sketch for the steps that you're going to follow, like this one. And then you start with the given with its unit, multiply it with a fraction. Always keep in mind to cancel the unit, it should be once in the numerator and once in the denominator. As you can see, to cancel grams of potassium chlorate, we multiply it with a fraction with its denominator, grams of potassium chlorate. And then to cancel moles of potassium chlorate, we multiplied with another fraction with its denominator, moles of potassium chlorate. And we continue doing the same. To cancel the unit in the numerator, we put it in the next fraction in the denominator. We continue doing this till we end up with the unit that we want for the final answer. And now you are ready to solve the end of video questions. Please, if you are not, repeat the video again. Otherwise, solve the questions, put your answer in the comment section. If you have any question that I didn't cover in the video, please share it with me in the comment section. Share this video with your friends. Subscribe to my channel to stay tuned for more videos. See you in other videos and good luck.